I find it easier to use the Pythagorean theorem than to use that formula. For example, let's start with the midpoint. The midpoint is just the average of the x's and the average of the y's. So the x values are 3 and -4. So we will have 3 plus -4, add them up and divide by 2, comma, the average of the y's, which will be 6 plus -1, add them up, divide by 2. When you do the arithmetic, you then have -1/2, comma, 5/2 as the midpoint of the line segment joining these 2 points. When it comes to the distance formula between these 2 points, I, instead of going straight to the formula, like to sometimes draw a real quick picture. Here we go. Our first point is located at 3, 6, so 3 to the right and 6 up. And the second point is at -4, -1 right there. So it's almost as if we have a right triangle here. To go from 3 to -4, here's 3 on the right, -4 on the left, this base is 7 units. And to go from a height of -1 up to a height of 6, that is a height of 7. So we are going to have 7 squared plus 7 squared equals our distance squared by the Pythagorean theorem. This is 49 plus 49 equals d squared, and d will equal the square root of 48. d squared equals 98, and d equals 7 root 2. And if you remember your 45, 45, 90 triangles from your geometry or trig class, you would know that this is a 7, 7, 7 root 2 special triangle. Now we want to determine if these 3 points form the vertices of a right triangle. What I'm going to do is begin by labeling the 3 points as A, B, and C. And now we're going to find the distance between each pair of points, beginning with the distance between A and B. Now we will need to use the distance formula. So we're going to have the difference of the x's, so we're going to have 3 minus a -6 quantity squared plus 1 minus 2 quantity squared, all inside the square root. The first parenthesis gives us 9, the second parenthesis gives us 1, so this becomes the square root of 81 plus 1, which is the square root of 82. That's the distance between points A and B. Now let's move on and find the distance between points A and C. This will be the square root of 1 minus -6 quantity squared plus -2 minus 2 quantity squared. We have -7 and -4, which square to 49 and 16. 49 plus 16 gives us the square root of 65. Finally, we need to find the distance between the points B and C. One more distance formula. This time we will have 3 minus 1 quantity squared plus 1 minus -2 quantity squared. We're going to have a 2 in the first parentheses and a 3 in the second parentheses. Squaring these, we will have 4 plus 9, which gives us the square root of 13. Now the question is, do these values obey the Pythagorean theorem? And if you check it, if you take the 2 smaller values, the square root of 13 and the square root of 65, the sum of their squares is not equal to square root of 82 squared. In other words, 13 plus 65 is not equal to 82. And we can then conclude that no, the points do not form a right triangle.